Hello, my name is Scott Cheatham and I'm with the Richmond Hospital Education Program. And today we're going to be doing an activity on reviewing linear equations and linear functions. This activity is designed for a variety of different age groups and classes. If you have taken Algebra 1, you have covered all of this material. And so whether this is used as a review at the end of the Algebra 1 course or as a refresher in either Algebra 2 or geometry or even trigonometry before you get into some of the more advanced topics with linear equations and functions, this could be helpful there as well. And so there are going to be some times where I'm going to, as we go through this, let you pause it or even just do the activity and then come back to listen to some of the explanations as we go through these problems. And for this activity, you're going to need an internet-connected device that has a camera. So whether you want to use a smartphone, a tablet, a Chromebook, anything like that will work if you want to do the activity portion of it. If you just want to kind of work through the problems as I go through them, you can listen along and work through this video. But I think you'll get a little more enjoyment out of it if you can use the QR codes. You are going to want to have access to a calculator. I think a graphing calculator such as what's on Desmos would be more than sufficient for you, but if you have a Texas Instruments calculator or a Casio or anything else, that will work as well. The way the activity works is you may have the printout of all the different stations. What you're going to do is you're going to solve the problem and then you're going to scan the QR code to see the answers. There's a number of different ways that you might come across and come to the answers for each station. So while I'm going to give you the answers and kind of walk through some of the different ways you could do it, there's not typically going to be only one way where you could arrive at these answers. So depending on how you learned it or how you've approached the problem, it might be different than someone else's, and that's okay. And as we go through this, through the video, feel free to watch it all, or if there's just one station that you had a hard time with that you want to skip forward to, feel free to do that as well. I'm going to go through the stations in order, talking a little bit about each problem, and then kind of going over how to arrive at each answer. So for station A, you were determining the midpoint of a line segment joining 2 points. And then for the second question, find in gradient intercept form the equation that goes through those given pieces of information. In this activity, if you see the word gradient, you might have also understand that as the word slope. Both are interchangeable in algebra, and so depending on how you learned it, you might have heard a different word, but just know that gradient and slope are interchangeable. On these, I'm going to also then put up the QR code. So if you want to scan this computer screen, it will work just the same. I don't call them each station's answer on the subsequent slides. I just put up the QR code and know that if you just want to see the answer for one particular station, you can scan that and go to it as well. So for this station here, we're coming up with finding the midpoint. One thing about midpoint is another way that you can kind of think about it is it's the average of the 2 points. That's really what the midpoint formula is. You add the 2 points together and divide by 2. Because we're adding, it doesn't matter what you think of as the first point or the second point. And so when you add them together, you get 10 over 2 or 5 as your x value, and then you end up with 3 over 2 as your y value. For the most part, in any math class in high school, you're going to leave things as an improper fraction. So rather than writing 1.5 or 1 1/2, we're going to write it as 3 1/2. Now find in gradient intercept or slope intercept form the equation of the line that goes through. For part A, they give you a slope or a point and the slope. And so there's a couple different ways that people solve for that. You might plug into point slope form, which is going to be y minus y1 equals m, or your slope, times x minus x1, and work that out. Some people plug into the slope intercept form, which is y equals mx plus b. They plug in the x and the y that they have, and so they would plug those in and then solve for b, In this case, when they do that, is 5. So there's multiple ways you could do that for letter A. And so as long as you got y equals negative 3x plus 5, that's fine. Note they did want you to write it in slope-intercept form, so you do need to have it in this form and not like a standard form such as 3x plus y equals 5. So you want to have it in this form. For B here, you're given 2 points. So the first thing that we need to do is kind of work to find the slope. And so again, that's going to be y2 minus y1 over x2 minus x1. And when you evaluate that, you get negative 3 halves. And so from there, it then becomes a question very similar to how you solve for A. And whether you use the point 3, negative 2 or negative 1, 4 is really up to you. I sometimes suggest using the one that looks a little easier. So if that's one that's got all positive numbers or maybe a 0 or smaller numbers, no fractions, that's fine. Here, really any one, they look pretty similar in kind of how you would have to approach them. And again, if you can use, I think the point slope form, which is y minus y1 equals m times the quantity of x minus x1. I think that's the best way to do it. But there are some other strategies out there. And again, when you get your answer, we're going to leave it in improper fractions for those values there. For station B, it starts with asking, okay, where does find the gradient of each of the following lines, or find the slope? And then you've got some other problems with 4 and 5. 4 there, you're finding where it cuts the axes. And for number 5, it's just asked, does that point lie on this equation? So let's look at kind of how we would approach each one of these. Now you'll notice for number 3 here, we're actually not given the coordinates. We're not given a coordinate plane with x and y coordinates, so we can then work to be able to find the slope and use the slope formula. So here we've got to think of slope more as change in y over change in x. So I think of it, count your y first, go up or down, and then always go right. But the other thing to keep in mind is going up or going right, that's going to be considered a positive movement. If you're counting down or left, that's going to be a negative. If you do end up with 2 negatives, they're going to cancel out and make the slope positive. So really it just depends on where you start counting from. But you got your fractions here. You got 2/3, 4, and negative 3 over 2, depending on where you counted from. You would have reduced and gotten the same final answers. And if you look at those, A and B, they have positive slopes, and our slopes there are positive. C is the one that goes slopes negative. D is one where it's undefined, and that's something where it's important to remember that the slope of a vertical line is undefined. The slope of a horizontal line is going to be 0, and those two facts are going to be really important for you to understand and commit to memory. For problem 4, it says find where the following lines cut the axes. And so where it cuts the axes is basically where, if it cuts the x-axis, that's where y is 0. And where it cuts the y-axis, that's where x is 0. And so that kind of opposite value being 0 is what you need to plug in for. So for 4a, if I wanted to know where it cuts the x-axis, I plug in 0 for y. If I want to know where it hits the y-axis, I plug in 0 for x. And so here, the answer is given just what the x-intercept was. If you wrote yours as a coordinate, that's fine. Both of those are fine ways to write it. You would have to do some moving around to solving for each one of those. And then for the number 5 there, does 2, negative 5 lie on the line in question? Well, all you do is plug in the x value for 2 and the y value for negative 5. And when you do that, you end up getting that 0 on the left, and that does equal 0 on the right, so you get a true statement. And so because it's a true statement, then we understand that that point does lie on that line. All right, station C, we've got 2 lines here, but one of them has a variable k. So find k if the lines are parallel, or find k if the lines are perpendicular. Well, the first thing I want to do for number 6 is recognize that It's written as 3 minus 4x. I might flip that around to be negative 4x plus 3. And then I might go ahead and move some things around on the 3x plus ky. What I want to just, as I approach this and as I move some things around, understand that the slopes, if they are parallel lines, are going to be the same. And if they're perpendicular lines, are going to be the opposite reciprocal. And so depending on what you're trying to solve for, that's going to be a different value there. Now for number 7 here, I'm using graphical methods, so using graphing calculator, where the line, where the line through those 2 points meets the line with the equation 3x plus 2y minus 7. So let's first talk about the number 6, and then we'll look at number 7. And so the slope there is going to be negative 4. So for 6, we want to know, okay, well, if we isolated y and solve for m, we want to know when is it going to be negative 4, what value of k would give us a slope of negative 4, and then for perpendicular, we want to know what would give us a slope of 1/4. And so you kind of have to work through each one of those to solve. The values to give us that are, for a is k is 3/4, and b, k is negative 12. Now for negative 5, 0, and 310, the line that's going to go through that, you're going to have to determine that. They've got it written here in standard form, 3x plus 2y minus 7 equals 0. You might have solved it in slope-intercept form, which would be y equals negative 3 halves times x minus, or plus 7 halves. Either way is fine. And then you have to find where they solve. The nice thing with the Desmos calculator is it doesn't matter what form you plug it in. You can have y equals, or you can have it in standard form like this. It will graph it for you. And so then you can go ahead and solve both of those to get the values where they intersect here at negative 1, 5. So station D, find the equation of the line that's horizontal through negative 4, 3, or vertical through negative 6, 1. You do need to remember we have the slope is 0 for horizontal lines and undefined for vertical lines. The other thing to remember, for horizontal lines, it's going to be y equals the y coordinate. For vertical lines, it's going to be x equals the x coordinate. For number 9 there, find the equation of the perpendicular bisector of the line segment of joining 7, negative 1, and negative 3, 5. So we'll come to that one in just a minute. So as I said, for horizontal lines, it's going to be y equals, and it's going to be y equals the y coordinate, which in this case is 3. And then for B, it's a vertical line. It's going to be x equals the x coordinate, which is negative 6. For 9, find the equation of the perpendicular bisector. So there's 2 important things to recognize there. One, it's going to be perpendicular to that line segment. And then 2, it's going to bisect it, meaning it's going to go through the midpoint. So we need to first learn what the slope is between those 2 points, and then we need to determine the midpoint. The slope, you're going to have negative 1 minus 5, which would be negative 6, over 7 minus negative 3, which would be 10. So we have negative 6 over 10, or negative 3/5. The slope for the perpendicular bisector then is going to be the opposite reciprocal, which would be 5/3. You then need to figure out what point that 5/3 slope is going through, and you take the midpoint there. So it's going to be 7 plus negative 3, which is divided by 2. So that's 4 divided by 2, or 2. For the y coordinate, you get negative 1 plus 5, which is 4 divided by 2, which is also 2. So we get a midpoint of 2, 2. And then from there, we can plug in and solve. You might have written it in standard form like this, or you might have written it in y equals mx plus b, or slope-intercept form, in which case you would have 5/3 x minus 4/3. Sometimes they write it in standard form to just avoid writing things with fractions, but there's no problem with writing things with fractions. All right, so we have a circle here, so it has a center of 3, 2, and a radius of 5. The points 8, 2, and 6, -2 are on the circle, meaning they are a distance of 5 away from that center. Find the midpoint of chord AB, and find the equation of the perpendicular bisector of that chord, and then show that the perpendicular bisector passes through the center 3, 2. So the first thing to do is to find the midpoint of chord AB. A chord on a circle is just a line segment where the endpoints are on the circle. And again, to find the midpoint, we just take the average. So 8 plus 6 divided by 2, 2 plus -2 divided by 2. In that case, you're going to get your midpoint. That midpoint there is going to be 7, 0. Find the equation of the perpendicular bisector of the chord. So we've gotten the midpoint of the chord. If we want to know the perpendicular bisector, it's going to have the perpendicular slope, which is going to be that opposite reciprocal there. And then we can work to solve. This is x plus 2y minus 7 equals 0. You might have had y equals 1/2 x minus 7 half, or plus 7 halves. Either is okay. And then show that the perpendicular bisector passes through the center. That's just plugging in the coordinates there, 3, 2. And when you do that, you get a true statement. You get 0 equals 0. Or you would end up with 7 equals 7, depending on how you solved it. Either way, that is correct. Station F. So find here in general form the equation of the line through, again, we have a coordinate and a slope, and then we have 2 points that we have to solve for. And then find, we have 2 equations here in standard form. Find the value of k, which would make them parallel and perpendicular. This one is hopefully similar to a previous station we did, so hopefully you felt pretty good about this. Although they did get a little bit more complicated with the fractions for this one. And so here, again, the point slope form is going to be y minus y1 equals m times the quantity, or the parentheses, x minus x1. They did want it in general form, or sometimes that's called standard form. You might see it equals 0, or you might see that minus 17 over on the right there. So that's one difference here. You want to make sure you had it in the right form. For part B there, you need to figure out the slope. And then from there, it didn't matter which value or which point you used for your calculating the line. If you assume you calculated the slope correctly, both of those would work. Now for number 2 there, again, for parallel lines, we want to have them to have the same slope and perpendicular, the opposite reciprocal. And so I think the best thing to do would be for number 2 would be to isolate the y, and that way you can know what slope you're trying to work with there. So when you would move that negative 5x and that minus 8 over, and then divide by negative 7, you would get the slope of that line would be 5/7. So parallel lines, you would want the k value that would give you 5/7. Perpendicular line, you would want the opposite reciprocal, or negative 7/5. And so there are your k values, negative 21/5 and 15/7 that would give us that. Now, a point T is on the y-axis is 3 units from the point negative 1, 2. Find the possible coordinates of T and the equation of the line AT given that T has a positive y coordinate. So this one was a little bit tricky. So when you look at this one, the point T is on the y-axis and is 3 units from that point. So we actually have to use what is called the distance formula. And so when you take the distance formula, that's a formula that you were actually not given, and it's one that you want to make sure that you feel comfortable with. It's derived from actually the Pythagorean theorem. And so you end up with the square root of x1 minus x2 plus squared plus y1 minus y2 squared. And so it's derived, you can also, if you think of it as drawing kind of a right triangle, you're finding the horizontal distance and the vertical distance. And then you're going to use that to determine what the hypotenuse or what that distance will be between them. And so that distance formula there, you get 2 plus or minus the square root of 8, depending on which way you were looking for it. Because we're told that the y coordinate is positive, we are going to use the 2 plus the square root of 8, and then you're going to plug that in to find using point A to find the equation. All right, so a truck driver plots his day's travel on the graph, find the slope of AB, and then find the slope or gradient of OC, so that's going to be the origin to C, and interpret the answers. What does that mean? And if you look at the graph, he's got distance and then time in hours. So let's first just look at A and B, and then we'll talk about what it means. So A and B here, the slope there is 50. And then from O to C, the slope is 82. And so if we look at that, we've got distance and time. So the steeper the slope, or the greater the slope, that's going to mean he's going to be traveling more distance in a shorter amount of time. So when it was a less of a slope, as it was between A and B, that means he wasn't traveling as much distance in that time. So you can think of it as he was going slower. So the gradient or the slope between A and B is the average speed the truck was going between points A and B, whereas the slope between OC is his average speed for the entire trip. And you also might have said, okay, well, he went faster overall for the entire trip than he did between points A and B. All right, so we have two schools that are located at these 2 points, P and Q, on a map. The local council wishes to zone the region so that children must attend the closest school to their place of residence. What is the equation of the line that forms this boundary? Now, one way of looking at this is, so we want to find what is the point that is going to be exactly between them. So you can think of that as the midpoint. And then we need to make a line that's going to go out from the midpoint that basically is going to be the perpendicular bisector. So to do that, to find the midpoint, we're going to, again, take the average of the points, so add them and divide by 2. We do need to know the slope between those two. So again, the slope is y2 minus y1 over x2 minus x1. So you could have 4 minus 12, which would be negative 8, over 9 minus 5, which is 4. So the slope there would end up being negative 2. For the perpendicular bisector, we want the opposite of that negative 2, or for the slope to be 1/2. And so we want the slope to be 1/2, it to go through the midpoint of those. That is, I'm going to give us some fractions. And you probably wrote it as y equals 1/2 x plus 9/2, or you could have written it in the general form written above there. All right, in our last station here, we have consider these points, A, B, C, and D. Use the slope to show that AB is parallel to DC and that BC is parallel to AD. What kind of figure is that? And then check that those two, AB is equal to DC and BC is equal to AD using the distance formula. So let's stop there and kind of look at those answers. So when you plug into the slope formula for A, B, and DC, you get a slope of negative 1/4. And because they're equal, that means that they are parallel. For BC and AD, you plug in, you get slopes of 3/5 for both of them, meaning that their slopes are also the same and parallel. So if you draw ABCD, these sides that we just figured out were parallel are really the opposite sides. So we've got a four-sided shape, a quadrilateral, where the opposite sides are parallel. And so think back to geometry and even back into middle school, Math 8, that's the definition of a parallelogram. And then we're going to check that they're equal. One of the properties of parallelograms is that not only are opposite sides equal, but opposite sides are congruent or the same length. So when you plug into the distance formula, you end up getting the same values for both of them. Now with parallelograms, there are some properties that come out with the diagonals. So one of the things is that the diagonals of the parallelogram bisect each other, meaning that where they cross and intersect should split the diagonals in half. And so for part D, when we're finding the midpoints of those diagonals, we end up with, for AC and BD, the midpoints, we get the exact same point. That would tell us that where they intersect is also the midpoint of each one of those diagonals, fulfilling the property of parallelograms that they bisect each other. I hope this review has been helpful for you. You might have approached some of these a little bit differently, but some of the same formulas and approaching them are ones that are going to be really helpful for you, either as you review previous Algebra 1 content or get ready to go into more advanced things in geometry and Algebra 2 and beyond. If you want some more practice, the Richmond Hospital Education Program has a subscription to IXL, and in Algebra 1, the unit S is on linear functions, and there's a number of great things that will be valuable for you to review in there. But again, I thank you for your time, and I hope this activity was a good experience for you. I wish you well with the rest of your school year. Thank you.